All right, so exponential and logarithmic equations. We've solved a little of both in previous lessons. These are going to be the more, not necessarily difficult, just a little more involved than the ones we've done before. But don't forget that you've learned the other kind because they will show up in Math Excel and on your test. So if you can make the bases match, then set the exponents equal. That's the easiest way to solve. If you cannot make the bases match, like if it was something like 2 to the x is equal to 6, then you have to use logs to solve exponents. Remember, I told you in a previous lesson that logarithms were invented to find exponents that we couldn't find. So this is where we're going to be doing that. All right, so the steps are to isolate the exponential expression, take the log of both sides. You can do common log or natural log. Now, in Algebra 2, you were taught a different way of doing this, and that's because you had the graphing calculator that had the fancy thing where you could change the base of your log to whatever you wanted. With the calculators that you're allowed to use in college algebra, you are only allowed a common log or a natural log because that's the only buttons that exist on your calculator. I tend to do the common log unless there's an E in the problem, and then I'll do the natural log because it makes it easier. Once you've taken log of both sides, then you should have something that looks not necessarily normal because it's going to have a log in it, but you should be able to get the variable by itself and then use your calculator to get a decimal answer. All right, so what does that look like? So for number 1, we're going to take log of both sides. And then we're going to use the property that says we can take an exponent and swing it to the front. Then we're going to remember that logs are really just a number. This is just a weird decimal. This is just a weird decimal. So if I want to get x by itself, I can divide by 2 log 5. And then in my calculator, I just type this log 13 divided by 2 log 5. Now make sure that you're paying attention. Your calculator will probably open a parenthesis here, so make sure you close it before you hit divide. And then all of this needs to be in parentheses, and then this is going to be in its own little set. So you've got to make sure that you tell the calculator what the order of operations needs to look like, and it doesn't make it up for itself. Not really make it up, but you know what I mean. So if I do log of 13 divided by 2 log of 5 with all of the right parentheses in there, I get 0.7968 yada yada yada. I believe on your test it tells you to round to 4 decimal places. That's what I'm going to do here. All right, so number 2. Again, we're going to take log of both sides. Since this base is a 10, log base 10 is actually super helpful. So the common log. Because log base 10 of 10 cancels, and this side is just negative x. It's just 1. So now we have negative x is equal to log of 8,000. So we divide by negative 1 to get x by itself. And so in our calculator, we can just type in negative log of 8,000. And I get negative 3.9031 if you round correctly. I definitely said that started with a 3, right? Yep. Negative 3.9031. All right, number 3, we need to get the thing that's raised to a power by itself. So we're going to subtract 5 on both sides. We are going to divide by 7 on both sides. In my mind that was going to work out to a nice number, and I wasn't seeing it happen. So I used my calculator, and it does work out to be a decimal. So I'm going to leave it 53/7 so that I'm not rounding in the middle of the problem. Oh, look, my problem was I should have added 5. Mercy. Let's start over. All right, so add 5 to both sides makes a whole lot more sense. So then when we divide by 7, it does work out to a nice number. All right, so then since the base is e, we're going to do the natural log. We're going to take the ln of both sides. So then x squared, because ln of e will cancel out, is equal to ln of 9. And then to get x by itself, we would take the square root of both sides. So we will get plus or minus whatever the ln of 9 is, or the square root of the ln of 9. And I get 1.4823. All right, so number 4, again, we have e, so we're going to do natural log. And then ln of e cancels out, so negative 5x squared, that exponent just falls down. We will divide by negative 5. So x squared will equal whatever ln of 14 divided by negative 5 is. So if you haven't picked up on it, I try not to do any like division that's going to give me a decimal until the very end. I'm not going to type that log in and get a decimal until the very end. So I just keep up with all the math that I'm doing and type it all in at one time. So now in the calculator, we'll do the square root of ln of 14. Don't forget to close the parenthesis after that 14. And then divide negative 5. Make sure all of that is under your square root or in parentheses behind your square root. And you get that you cannot do it. When you try to do that in your calculator, it should give you an error message, and it's because the ln of 14 is positive and we're dividing by a negative. So if I try to take the square root of a negative, that's not possible. So we're going to say no solution, or at least there's no real solution. All right, so number 5, you have an exponential on both sides. Both sides of the equation have something raised to a power. So we're going to take ln of both sides because there's an e involved. So we'll do ln of e to the x plus 3 is equal to ln of 20 to the x. So again, these guys cancel out, and this is just x plus 3. This x can swing to the front, so it'll be x times ln of 20. All right, so now I need my x's on the same side. So we're going to subtract x. And I need you to be careful. Here they cancel because that's a plain x minus a plain x. And the 3 comes down. Here they don't cancel because this x is being multiplied by ln of 20. So if you think about it as x ln 20 minus x, I can factor an x out and have ln of 20 left here and 1 left here. So that's how I'm going to write it. So now to get x by itself, I can divide by that ln 20 minus 1 on both sides. And that's what's going in my calculator. But again, make sure that the order of operations works. So when you type this in, it should be 3 divide parenthesis ln parenthesis 20 close parenthesis minus 1 and then close the one that you started over here. So this is what goes in the calculator for this. Since we don't have magic fraction buttons and things like that on the calculator we get to use in this class. And I'll type that in mine and let's see what we get. I get 1.5032. All right, so number 6, there's no 10, there's no e. So common log, natural log, whatever makes you happy. Again, unless there's an e in the problem, I tend to use the common log, and there's really no rhyme or reason. One works just as well as the other. All right, so then we're going to swing our exponent to the front. Swing this exponent to the front. All right, so then we have to distribute. So we would get 2x log 3 minus 5 log 3 equals x log 7. And again, we want x's on the same side, so we'll do minus 2x log 3 on both sides. So we have negative 5 log 3 equal to, here if we factor out an x, then we have log 7 left from the first part, and then minus 2 log 3 from the back part, this piece. And then we can divide that parenthesis to the other side to get x by itself. All right, and then so many parentheses that have to go in the calculator. So in your calculator, to find x, we're going to need negative 5 log 3 in its own parenthesis divided by, and then this log 7 minus 2 log 3 in a parenthesis. There it goes. All right, so all of those parentheses are necessary to make sure that the order of operations is followed. And I get 21.8573. All right, so that's how we solve exponential equations when we cannot make the bases match. All right, so for log equations, so first of all, remember that we learned for logs that if we had something that said log base 2 of x is equal to log base 2 of 7, we would know that x is equal to 7. We've used that in a previous lesson. I believe we may be learning that today now that I mention it. We also, I think, have learned this in a previous lesson that you can take log and write it in exponential form, and that's a way to solve. So we'll just jump in and see. The thing that's most important, though, to you to make sure that you don't forget is that for log equations, you must check your answers. That is required on a test, and occasionally it's necessary to be able to throw out an answer. All right, so for number 7, you have a single log equal to a number. Those are the easy kind. You're going to use the loop trick, write it in exponential form. So base to the answer equals the guts. So 2 to the third is equal to x minus 4. We know 2 to the third is 8. We add 4 to both sides, and we get that x is 12. All right, so then to check that, we just go back and make sure that the math works out and there's nothing illegal happening. So this would become log base 2 of 8 is equal to 3, and then we know 2 to the third is equal to 8, so yay. All right, number 8. The easiest way to do this one is to use that property that I was discussing a minute ago. If I add this log to the other side, then I have log base 5 of x is equal to log base 5 of 4x minus 1. So then since these logs match the same operations being done on both sides, I can ignore it and say that x is equal to 4x minus 1. subtract 4x from both sides, divide by -3 on both sides, and x is equal to 1/3. All right, so then to check that, we go back into the original and we say log base 5 of 1/3 is equal to log base, nope, that says minus, my fault. Pushing buttons and nothing's happening. If you're wondering what the pause is about, I don't know why that stopped on me. All right, so minus log base 5 of 4 times 1/3 minus 1 is equal to 0. All right, so log base 5 of 1/3 minus, if I do the math here, this is 4/3 minus 1 or minus 3/3. So 4/3 minus 3/3 is 1/3. And then something minus itself is 0. All right, number 9, we cannot just move one log to the other side because the other side has a number other than 0. So we are going to have to condense. So remember with addition, we condense with multiplication. So this will be log of x times x minus 3. So that would be x squared minus 3x. Remember, there's an understood base of 10. So when I write this in exponential form, it becomes 10 to the first is equal to x squared minus 3x. And that's again using that loop trick. The base to the answer equals the guts. All right, so now we're essentially solving a quadratic. So we're going to subtract 10 from both sides. Generally, these are going to factor. Occasionally, like in Math Excel or something, they'll be like mean to you and it won't factor, but on a test, it should factor. All right, so x minus 5, x plus 2 will work to get us -10 when we multiply, -3 when we add. Remember that you always have to write down this step, or I have to take an entire point off for every problem that you don't do that on. They also like to see that you add 5 and you subtract 2. What did you do? Don't leave it to the imagination. So x is 5, x is -2. Now, generally, when you get two answers, one of them is not going to work. I'm not saying always, just generally. All right, so let's check the 5. So log 5 plus log of 5 minus 3 is equal to 1. So log 5 plus log 2 is equal to 1. So remember that we multiply when we condense addition. So this would be log of 10 is equal to 1. So log base 10 of 10 does equal 1. That one works. All right, so going back and trying the -2, log of -2 plus log of -2 minus 3 is equal to 1. You can stop right here and say cannot take log of a negative and you're done. That one does not work. So he is garbage. He is the answer. All right, so on the next one, because of this 4, we're going to have to add log to the other side so that we only have logs on one side of the problem. If you can get it to say log equals log, that's great. If you can't, then we have to get the logs on the same side and condense. So again, addition means we condense with multiplication. Remember, if it was subtraction, we would condense with division. All right, and again, we have a base of 10. So 10 to the 4th is equal to 7x. 10 to the 4th is 10,000. Divide by 7, and we get an answer of 1428.5714. 1,428.5714. All right. So I believe the next one is what we've already discussed. If you can make it log equal log, then you can ignore the logs because you're doing the same operation to both sides. So those can cancel out. And then always, always remember to check and that your arguments have to be bigger than 0. They cannot be 0. They cannot be a negative. All right, so for this one, we already have log equals log. So we'll do 3x is equal to 88 minus x squared. All right, that's a quadratic. So I need everybody on the same side equal to 0, and I like my x squared to be positive, so I'm going to add the x squared and subtract the 88 over here with the 3x. Make sure that it's in standard form, so x squared, then x, then the constant. And then we can work on factoring. I believe we can do plus 11 and minus 8. So that means that we get negative 11 and we get 8. All right, on that last question, I didn't check it, but you would check it the same way. I'm sorry that I didn't, I forgot. So on this one, we're going to say log 5 of 3 times negative 11 is equal to log base 5 of 88 minus negative 11 squared. All right, and as soon as you realize that this has log base 5 of negative 33, you can stop and say, nope, that doesn't work. We can't take the log of a negative. So then we can try the 8. Log base 5 of 3 times 8 equals log base 5 of 88 minus 8 squared. So this would be log base 5 of 24. This would be log base 5 of 88 minus 64, which is also 24. So then we can say, yes, that works. All right, number 12, we need to condense on both sides of the equal sign. So here they're being added, so we will multiply. So this will become log of 25x. Over here, they're being subtracted, so we will divide. It'll become log of 13 divided by x. So now we can ignore the logs. 25x is equal to 13 divided by x. So we need to times x to get that off of the denominator. So we will have 25x squared is equal to 13. Then we need to divide the 25 to get the x by itself. So x squared will equal 13 25ths. Then we can take the square root of both sides and have plus or minus the square root of 13 over regular 5. All right, so I'm just going to like walk you through this, talk you through it. Remember on a test, you have to actually write it out. If I take the positive of this, I'm not going to get a negative anywhere in my logs, so it's more than likely going to work. If I take the negative, then I can't take log of a negative, so we know the negative will not work. So I'm throwing out the negative and I'm keeping the positive. And then just to prove that it works, if you had root 13 over 5 times 25, well, 25 divided by 5 is 5, so you just have 5 root 13. And then here, if you had, okay, hold on, I'm going to write it down because that was a lot of talking and I'm betting that it didn't make a whole lot of sense. If I do this, if I multiply, the 5 makes a 25 of 5. So then I end up with log of 5 root 13. Hopefully you followed that. Well, on the other one, if I have log 13 minus log of root 13 over 5, then if I try to do 13 over root 13 over 5, that's going to be 13 times 5 over root 13, which will be, if I rationalize the denominator, these will become just 13 and cancel out that 13. So I'll just have 5 root 13 again. There's nothing that complicated on your test, so don't worry about it. Math Excel may throw it at you. Ask for help if you need it. But also in Math Excel, you can just understand that the negative one doesn't work, the positive one does, and be done with it. All right, so for this last one, actually, I don't know that this is the last one, I just assume. Let me see, is there a 14? There is not. This may actually be the last one. All right, so then over here, these are being subtracted. So when we condense, it'll become division. So then that means x minus 3 is equal to 7x minus 23 over x plus 1. So then we'll multiply the x plus 1 to both sides. So then this will multiply out to x squared minus 3x plus 1x, so minus 2x minus 3. Here they cancel, so it's just 7x minus 23. All right, so then we subtract 7x and add 23. So x squared minus 9x plus 20 is equal to 0. Then again, always try to factor because generally they're not mean enough that they give you something that will not factor in the middle of a problem like this. And then don't forget to show all of the steps to solve. I know in Algebra 2 you got used to not having to, but in this class, the tech people, for some reason, think that it's super necessary. So we get 5 and we get 4. And then to check, because I believe you do have one like this on your test, I'm going to go through the check with you. All right, so check in the 5. This becomes ln of 2 equals ln of 35 minus 23. So ln of 12 minus ln of 6. And then these you're going to divide. So then ln of 2 is equal to ln of 2. That one works. We can assume that the 4 does not, but that's not always the best choice because occasionally 2 answers will work. So go back and plug 4 in for all of your x's. And let's see if that works out. So this becomes ln of 1. This is ln of 28 minus 23, so 5. This is ln of 5. So we get ln of 1 is equal to 0. And then I believe that's also a true statement because remember that anything to the 0 power is equal to 1. So e to the 0 equals 1 is true. So this is an example of one where there are 2 answers. So make sure that you check both and don't assume things so you don't get yourself in trouble. All right, I was correct. That is all. You should have a chapter 4 test coming up right after this lesson. Make sure that you finished all of your assignments previous. Let me know if you have questions.